Good morning. I hope that you're all doing well right now, given the circumstances. We're going to continue on with Lesson 5 of Unit 9, the independent practice. And after I post this later today, I'm going to post the unit review, probably today or at the latest tomorrow. And then hopefully early next week, you'll be able to test on Unit 9. And then I will be posting our final unit, Unit 10, all next week. And we should be wrapping up the class within a week and a half to 2 weeks. Anyways, let's begin. So where we left off was the independent practice. And so we have problems 8 through 12, 24, 33, and 34. So I am going to start with problem 8. And this is from page 844 in the textbook. And we have a trapezoid that is labeled A, B, C, and D. And we have two congruent sides and 120. Sorry, I was doing problem 1. It is a trapezoid labeled A, B, C, and D. However, we have diagonals connecting the opposite sides or the opposite angles, and we have a intersection point at E of the diagonals. And it basically says find AC if BE is equal to 12 and ED is equal to 24. All right, so let's label what we know. So BE right here is 12. This portion right here, that's 12. I'll erase that 12 on top. And we know that ED is 24. And what they're asking for is AC, the length of the diagonal. So we know that AC is going to be equal or congruent to the length of BC because the diagonals in a trapezoid are congruent if the triangle or the trapezoid is an isosceles trapezoid. In this case, it is unknown. However, we can assume that for this example. So what we're going to do is just add ED plus BE. And that's going to give us 12 or 24 plus 12, which is 36. So we know that AC or the diagonal lengths are 36. So that is fairly simple. All you're going to do to find AC is you're going to add up BE and ED since the diagonals in the trapezoid are congruent. All right, so let's look at number 9. Number 9 has a trapezoid that is sideways right here. It's labeled E, H, F, and G. And we know it's an isosceles trapezoid because we have the congruent symbols. And we know that the opposite side lengths that aren't congruent, so basically E and H and F and G, they're parallel. And it says we want to know the measurement of angle F. And essentially, the measurement of H is 50 degrees. Well, according to the properties of trapezoids, basically the opposite angles add up to 180 degrees. So that means that the measurement of F plus the measurement of H equals 180 degrees. And what we're going to do to find the measurement of F is we're going to take 180 degrees and subtract 50, which gives us 130 degrees. So 180 degrees minus 50 degrees is equal to 130 degrees. So that is what the measurement of angle F is. All right, so I am going to let you do number 10 and 11 because they are identical or the same type of problems that we just went over. So you're going to have to do that on your own. Looking at the problems, I'm going to do number 12 for you, and I think I'm going to do 22, or sorry, no, 24 for sure. And then since 33 and 34 are the same type of problems, I'm going to do 12, 24, and 33. And then you can do 11 and 12 and 10, 11, and 12. Sorry, 10, 11, and 34 on your own. So again, I'm just going to go over problem 12, problem 24, and 33. And you're going to be responsible of doing 10, 11, and 34 on your own. All right, so let's look at number 12. So number 12 it's kind of like what we did in the guided practice. We are given 4 vertices for this trapezoid. So what we're going to do is first graph this trapezoid. So I'm creating my X and Y axis. So I have -6, 1, 2, 3, 4, 5, 6, and -3. So A is right there. B is at -4 and -1, so it's right there. C is at 1, 1, and D is at 3, -3. So right about here. And I just need to double check. Yep, so that is correct. I thought it could have been 1, -1, but in fact it is not. And B, I drew incorrectly. It's at -4, 1. Okay, so that looks more correct. All right, so I'm just going to draw this trapezoid. And notice B and C and A and D, they are on the same y coordinate. So A and D are both at -3 and B and C are both at 1. So I know that their slopes are going to be 0 and that they're parallel. However, I know the book wants you to find their actual slopes using the slope formula, but an easy way to double check your work is if the y value for both B and C is at the same y value, so notice how it's at 1, so C is at 1, 1, and B is at -4, 1, we know that they're going to have a slope of 0 because it's a horizontal line. A and D, its y value is at -3, and so we know the slope is also going to be 0. That's a quick way to do this. However, the book wants you to use the slope formula, which is y2 minus y1 over x2 minus x1. So we're going to take b's coordinate, which is at -4, 1, and c's coordinate, which is at 1, 1, and plug it into the slope formula. So we're going to go 1 minus 1, 1 minus 1 over -4 minus 1. So that's going to be 0 over -5, which is 0. And we're going to do the same thing for AD. So we're going to plug in the coordinates for A, which is -6, -3, and plug in the coordinate of D, which is at 3, -3. And so we're just going to go -3 minus a -3 over -6 minus 3. And that's going to give us 0 over -9, which is 0. So since these slopes are the same, we're going to draw, like I did earlier, two parallel symbols, those arrows. Okay, so that's the first step that we had to do for determining if this trapezoid is a isosceles trapezoid. Now the book wants you to do step 2, which is find the distance for A and B and C and D. Because if the distance for A and B, so if A and B's distance is equal to C's and D's distance, we know that it's an isosceles trapezoid, because an isosceles trapezoid by definition has two sides that have a slope of 0, meaning they're horizontal, and then the other two side lengths are equal to each other. So let's look at that right now. Okay, so for this step, for AB and for CD, we're going to use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. And again, it's the square root of what I just said. So the square root of x2 minus x1 squared plus y2 minus y1 squared. So the coordinates for AB we have are at -6, -3, and -4, 1. So doing the math, we're going to have -6 minus a -4 squared plus -3 minus 1 squared. And that's going to give us -6 plus 4 squared. So that's the square root of -2 squared plus -4 squared. So that's going to be 4 plus 16. So that's going to be the square root of 20. So if we figure out and have CD equaling the square root of 20, we know that by definition, since these two side lengths, A, B, and CD, are congruent, that it is an isosceles trapezoid. So I'm going to do the same thing. I'm going to have 1 and 1 for C and 3 and -3 for D, and we're just going to plug it in to that formula. So we're going to go 3 minus 1 squared plus 1 minus a -3 squared, and that's going to give